We started down this pathway on Thursday, right before you took the quiz. I showed you how to do something, and then you guys plowed through a big long Delta math assignment. So there shouldn't be a ton of stress here today. What we're going to be doing is writing equations of lines. But what I wanted to make sure of with this particular assignment is that if I said to you, so this is based on your prior knowledge, things that you learned prior to today. If I said, write the equation of this line, what problem or issue would you run into? And I can zoom in a little bit more if you'd like. And by a little bit, I guess I mean a lot bit. What's the dilemma? Say again, bud. It does, but it's just not in a good place, is it? Right. So I wanted to make sure that you got to see this, that not all y-intercepts are cute and fuzzy. And sometimes you can reason your way through. Like in this case, you could probably reason your way to what the y-intercept actually is. But a lot of times you can't. And so what we're going to do today, and I put it in all capital letters. I don't know if yeah. So in the assignment, same way, I caps locked my expectation. And so when you write your equations today, you're not going to be striving for y equals mx plus b. What we're going to strive for is point slope. And it is time today for me, this part you can write down. It's time for us to talk about what is point slope. And so the point slope form of an equation looks like this. And that's worth writing down because you now are in possession of two formats of linear equations. The one that we've been attacking relentlessly for a couple of weeks is slope intercept, you'll remember. And I'll write that one up here, even though I know you've already got it somewhere. But slope intercept is the one that is y equals mx plus b. And so we became very familiar with that, very comfortable with the fact that there's a y and an x, and then the m is the slope and the b is where it crosses the y-axis. So we're going to become very familiar today with the purple one, the point slope. And just like you learned on Thursday, if you were here, it's just a matter of inputting things in their certain spots. And so this is the general form of a point slope equation. And what we're going to do is we're going to input things here, here, and here. You'll notice that I don't have any arrows pointing at the y and the x. Those are not going to change, okay? Those are going to remain there structurally. So in place of where the yellow arrow's pointing, that's where your y coordinate will go. And this will make a lot more sense in just a moment, okay? What's going to go in place of m? The slope. No shocker there, right? So the x or the y1, that's just a subscript, by the way. It's not an exponent. It's just when we put little numbers down below things, they're labels. So we're just giving it a differentiation so that it looks different from the other y. So you could put like y sub happy face or something. Like it doesn't matter as long as you express that it's not y, but the replaceable y. And then in place of x1, what do you suppose we're going to put there? Right. So again, provided that you were here Thursday before the quiz, this is probably not a big news flash to you. You know that it was a simple matter of just dropping things into their proper places, right? So, for example, if I gave you a request, if I said, please write me the equation of a line that passes through the point -2, 11, and has a slope of -3/4. You can do it using point slope. I mean, you could do it other ways, but the quickest, easiest, most convenient way to do it is with point slope. So what would my purple equation change into if I used this information to write it? Y minus 11 equals, and then open parentheses.
2 plus, or 2.
There it is. So this is what I had hoped, is that by having you do that delta math after the quiz on Thursday, that you would just practice this skill enough that you would come to appreciate that, again, I'm just literally airdropping things in place of Y1, in place of M, and in place of X1, right? I didn't address it. I never wrote that purple thing at the top on Thursday, but that's the idea, is I'm just replacing 3 items with information that I'm given, and presto, I'm done. Okay. So, having said that, once you're done copying this down, I'm going to go back to the other page. And the question becomes, well, why is this important? Because I won't always be fortunate enough to see one of the key components that I may want to see. However, you can always find a point and a slope. Hence the beauty and the necessity of, well, point slope form. Okay? So I'm going to head back over here. And now to write the equation of this line, the 2 things that I need are a point and a slope. Now, Aubrey might say, I like this point. And Embry might say, well, I kind of like this point. And Macy might say, I think you're both crazy. I like the green point. I mean, I could go on and on. Sometimes you're going to have lots and lots of options. There are 1, 2, 3 other points that I could have selected. Any one of them will do. What you're going to find with point slope is there's sometimes a lot of correct answers to these problems. So which one would you like to pick? Red, purple, or green? Purple's great. So what we're going to do first is we're going to write down the coordinates of the purple point. And what we now know is that based on what I see on the graph, my graph goes through the point 1, -1. If you had said green, then I would have written down 5, -3. If you had said red, then I would have said -5, 2. Right? That's sometimes a tough pill for people to swallow. It's like, wait, I can have multiple correct answers in point slope form? Yes, you can. It's virtually limitless. The other thing I need to use point slope is, of course, the slope. And we've been hitting this pretty hard now for a long time in this class. What is the slope of this line?
-1/2.
It is exactly that. Good job, Embry. No matter which 2 points you pick, the slope is always going to be down 1, right 2, down 1, right 2, down 1, right 2. You could do this over and over again. So we can now say that it goes through the point 1, -1, and has a slope of -1/2. So I'm taking the information that's in a graph that's visual, and I'm writing it down like this, and then I'm putting it into the format that we're familiar with from Thursday and 3 minutes ago. So what will my equation say for this problem? What would it be? Point slope.
1 plus 1.
Y plus 1 equals
-1.
-1/2 of. Beautiful. And just to be clear, if you had said, when I said, which of the points do you want? If you had said the green one, then I would have written down a different point. That 1, -1 wouldn't say that. It would say 5, -3. And how would that alter my equation? It certainly wouldn't look like this anymore. What would my equation be if I selected that point?
+3.
Not 1/2. Yes. And you could have picked the red point. You could have picked several other points and they would all be correct answers. What winds up happening is this version of your answer can be very different from one person to the next. But eventually, starting tomorrow or Wednesday, when we start coming back towards slope intercept, that's where we find the common ground. Is that, Aubrey and Seth and Cooper, they all might get different answers for their point slope equations. But when we convert them back to slope intercept, they should all come back to the same place. It's like magic. That is what you're practicing today. Let's practice it again. Number 2 appear on my paper. What's the first thing I need? A point. I don't want intercepts. I want a point.
Up 39.
This point will do. What are his coordinates? What's his name? 1, 3, because points are defined by their X and their Y, right? So we go 1, 3, boom, got it. What's the other thing I need? The slope. The slope will never, ever be up for debate or negotiation. So in order to find the slope, I do need a second point. And I look around and I think I've got to go all the way down to here to find another good point, a lattice point, right? So what is the slope of this line?
Oh,
I agree. Is anybody confused by either of those things? We found a point, and then of course we needed another point to find the slope. And now that I have those things written down, I'm just going to make an equation. Someone other than the same voices, could someone write me the point slope equation going through the purple point with the red slope? I'll take any voice other than the ones that are always the same. Rowdy?
Y minus 3. 5/3 of X minus 1.
Beautiful. And again, the question might arise, what if someone had selected the red point as their first point? That's okay. Then their point name would have been -2, -2. And their equation would have been y plus 2 equals 5/3 of x plus 2. And as hard as it might be for you to stomach or believe this today, those two answers in the green box are exactly the same. And I'll show you that when the time is right. Okay, question 3. What do we need? A point and, well, yes, a point and a slope, right? So yes, we do need 2 points eventually. So 3, -5, you say? Okay, so write 3. I love that point. And give me another one.
1, 2.
Yeah, those are the only good ones that I'm seeing on there. So which one would you like to use as our target point? Because we do have to commit to one.
Well, you could.
Let's use 1, 2. So we'll use the point 1, 2. And then what is the slope?
Or -7.
Now that I will accept. Since it goes downhill, it's got to be a negative, of course, right? The line looks like that. You put a negative on it. So what's my equation? Good.
How do you find the slope again? I kind of forgot.
Slope is found by just counting rise and run. So first off,
Oh.
I knew that the slope would be negative because the line goes downhill. And then I just counted 1, 2, 3, 4, 5, 6, 7, 1, 2, 7, 2.
Okay, yeah, I kind of.
You're good. It's important to ask if you're not sure. How about this one? I need a point and I need a slope. -1, 3 is a good point, and then I need a second one for some slope. I'll take it. And there was one other option up here, but I'll take the ones that you committed to. Which one would you like to use as our target point? Say again. -5, 0. So our point that we're going to commit to is -5, 0. And what is our slope?
3/4.
Perfect answer. Goes uphill at a rate of 3 to 4. Up 3, right 4. And that's what I need. If I can write those things down, then I can write an equation of a line. So what would the equation of this line be?
Y.
Yes, instead of putting y minus 0, you can just put y equals. It's a good choice to pick the one with the 0 as its y.
3/4
Equals 3/4 of.
of x plus 5.
Gorgeous. That answer would look completely different if when I said which point do you want to choose as your target or focus point, if Natalia had said the green one, then our structure looks completely different, but it does all come out in the wash. Okay. Number 5 here. Again, we need a point and we need a slope, right? Can you see a couple? Or give me 1 point to start, I guess. Yep, give me another one.
-5, -1.
Yeah, you got to go way over here to the, like way down to like South Carolina over there or something to find the next one. So which point do you want to be the focus? Okay, so the point that we're going to use is -3, 2, and I do need the slope. What is it?
It's -3.
It is. If I go down 3 and right 8, and I'm modeling for you right now what I would expect of you, and that is to write that point down and to write that slope down so that they look like what we want them. Like we want the information to be there for us so that we can just plug it right in. So what would this equation say?
X plus.
It's a cake. And again, the answer would be completely different if when I had said, which point do you want to focus on, if you had selected the screen. Right answer still just looks different. I realized that I probably could have quit this after 2 examples, but not everyone learns at the same pace, so we're going to do one more. I need a point. I think you mean -1, -4. I'll take it. So let's go ahead and just commit right now, Seth. That'll be our focus point. -1, -4. And what's the slope?
2.
I don't think I can find another lattice point
4.
until way here. You agree with that? I got to go up 8, I believe, and right 3. But it doesn't matter because again, I'm empowered now with the knowledge of point slope. So now I can just dive right in, go y plus 4 equals 8/3 of x plus 1. Done. That's how quick and easy a point slope is. Did I? If you go up 8, you're stuck here. You got to go right 1, 2, 3. Yeah, you didn't quite. You forgot to count that one shot back to the y-axis there. And there's a bunch of these. I don't think at this point that I need to do these. I think that I could just maybe pick 1 or 2 of them, but this is just the same thing, right, without the graph. So I had this in the lesson, but then I thought you don't need all this, right? So like if we were going to do this one, what would the answer be? It would be nice to hear some new voices. Like I can't stress enough. Those of you guys that never answer, it would be good to hear someone new. When the same 2 people keep answering my questions, it's just not good for anybody. Right? Or if we did this one, it would just be y minus 5 equals -4 times x plus 2. I mean, we could do this all day. Yeah, those should be 5-second problems, maybe 10 if you write slow. Got it? Okay, cool.
You enlarge that question there, please?